Hello everyone, it's July the 10th, Saturday. Alright, are we ready for today's hard question? I'm not, but we're going to do it anyway. Alright, let's take a look what we have. Decode ways. Number 2, it's a long question. A message containing letters A to Z can be encoded into numbers using the following mapping. To decode an encoded message, all the digits must be grouped and mapped back into the letters using the reverse of the mapping above. There can be multiple ways. For example, this can be mapped into AAJF or KJF. Note that the grouping KJF is the grouping of this is invalid because 06 cannot be mapped to F since the 6 is different from 06, okay? In addition to the mapping above, an encoded message may contain the star character, which can represent any digit from 1 to 9. 0 is excluded. For example, the encoding 1 something may represent any of this. Decode this is equivalent to decoding any of the encoded message it can represent. Given a string S containing digits and the star or asterisk character, return the number of ways to decode it. We have the modular. Okay, so that's 1 to 9. Each of these can be decoded, yeah. If 1 something, it's 1 to 9. Right, and decode it separately, 1 and 1 to 9, so that's 18. Yeah, each of them can have 2 ways to decode it. It can be A and a K. Yeah, 2 something. So again, 1 to 9. 1 to 9. It's 1 to 6 plus 9. That's 15. Okay, 10 to the 5th. Oh my God. Has to be ON. I don't think maybe ON log n we can pass, but most likely 10 to the 5th would be ON. 1 read. Oof. Okay, so man, dynamic programming. It's like every time, right? So we have a bunch of things. Let's take one example. Let's say 1 star, right? So how would you solve it? So we say dynamic programming. Look at the first character as 1. We say we have 1 way of doing it, and then we'll go on look at the second character, and the second character can be by itself, right? Can be by itself. But basically we say if we know the total number, right, the total number of decoding of n minus 1 characters, right, that's what we know. Now we have n plus 1. Now the nth, what is the total of nth? Now all n minus 1 we have a total number, right? We have a total number, that's good. Now n minus 1. All right, n minus 1, there are 2 situations. Either it is a digit or it's not. If it is a digit, if it's a digit from 1 to 9, right? It's actually 0 to 9. The digits is going to be 0 to 9. If it's a 0, what we know is it cannot be by itself. It has to be attached with the one, with the previous one. It has to be attached with the previous one. But it didn't say, what if I give you something that's not decodable? Oh, then that's going to become 0, right? Let's say we give it a 0. Right? This is going to return 0. Yeah? If I give a 3, 0, this is going to return 1. Oh no, this is going to return 0 as well. Yeah. So no matter what happens, I think this is going to be 0. Yeah, this is going to be 0 because no matter how much you can do when you hit 0, if the one up before 0 is larger than 2, then it's a no-go. Yeah, that's true. But it's the one before, then we have a go. This is going to give us some value. It is not 0. Yep, it's not 0. It has something, right? It has something. At least it's not 0. I mean, it could be 0. No, it will never be 0. Because there's always a way to interpret everything as a single one and then put 0, we bind it with something in the front. There's always a way. So it's going to be 1. So if it's 0, that's actually easy to check. Because 0 by itself, it's a no-go. And if we have a no-go on any character, then it's a no-go, right? So for 0, if the value in front of it is larger than 3, then it's a no-go. There's no way to incorporate the 0. 0 cannot be by itself. 0 I cannot combine with the previous one, so that's a no-go. So only if it's 1 or if it's 2. If it's a 0, 0, it's also a no-go. Because if it's a 0, 0, it cannot be by itself, it cannot combine. So the only thing that can work is if it's a 1 or if it's a 2. Right? If it's 1, then we need to combine 1, 0, and look at the 1, look at the one before it. See how many that we have. Right? How many the one before 1, total number, that will be the same 1. If it's 2, that's the same thing. So 0 is an interesting case. Now for all the other values, if we have 1, 2, 3, 4, 5, or 6, 1 to 6, they all represent, we also have to look at the values in front, right? So at least we know they can be by themselves. So we have that, right, by themselves. Whatever has happened previously, we're going by themselves. Another scenario will be we try to combine with the letter before. Now the letter before is interesting, right? So the letter cannot be 0. So right, the letter before can never be 0. If the letter before is 0, then that is a no-go. And letter before can be 1. If the letter before is 1, we actually can have 1 to 9. Actually 0 to 9. That's fine. If the letter before is 2, then it's 0 to 6. If the letter before is 3, then it's just 1. We only have 1. Alright? So, based on this, it might be possible to... Okay, so we only handled all the digits. I think digits is not that difficult to handle. We just need to be... and actually, when we see a value, right, we need to check the value before us. That we have a little bit less to check. The value before us, is like only 1, right? The only thing that we can take is if the value is 1 or 2. If the value before is 0, then we cannot combine. Now we're just talking about combining, right? If the value is 0, then we cannot combine. If my value is 0, then I have to combine. If my value is any other things, then it depends on the value before me. If the value before me is a 3 or larger, then we cannot combine. So basically, we say if n minus 1, if the value of n minus 1 is 0, or 3, 4, 5, all the way to 9, then there's no way to combine. We cannot combine the previous one and the current one, no matter what. We cannot combine. Now, if the n minus 1 give us 1, it's 1, and then we check the current value. If it's 0, then we have to combine. We need to look at the one before it, before the n minus 2. But look at n minus 2, right? So 0 is a special case. And the rest, 1 to 9, they can be by themselves. So get a copy of n minus 1, and they get a copy of n minus 2, right? So if n minus 1 is a 2, then 0 must combine. It's the same thing. Then if it's 1 to 6, then we can combine and we can do by itself. And it's 7, 8, 9, then it's only by themselves. So these can do combine, right? This has to combine. Combine and self. Combine and self. 7 to 9, it has to be self. There's no combination. All right. So that's that. What about asterisk? So the asterisk can represent anything. We're talking about anything, right? The asterisk can represent any digit from 1 to 9. 0 is excluded. So now we're talking about, still, if it's a 3, if the previous is a 3, then we, no matter what, we have to be self. So if it's this, then it has to be have different situation. Like if n minus 1 is 0 or 3 to 9, and if my current is 0, then that's a no-go. That's directly return 0, because we cannot decode it. It cannot be combined with the previous one, right? It cannot be by itself, and it's just a no-go. Yeah, it's a no-go. So each one is either by myself, or I combine with the previous one, or I combine with the one next to me. Let's actually have 3 situations. Hold on. Did we consider this? We will consider the 3 situations if we keep going, right? And we consider all the 3 situations. So for each one, I only need to consider the previous situation. So for 0, that is going to be a no-go, because whatever value we have, it's not 0, right? And then currently we'll have a 0. So we want to decode 0, right? So 0 cannot be decoded by itself. So 0 has to combine with the previous one. And then we say, we cannot combine with the previous one. So 0 has to combine with the next one. But 0 cannot be combined with the next one because we cannot do 0, 6. So if we have a n minus 1, which is 0, 3, 4, 5, 6, 7, 8, 9, and my current value is 0, then we just return 0 immediately. We can actually do one more test just to, So basically we say, doesn't matter what this is, we get a 0. Actually, let's go smaller value, so we make sure, right, it's definitely decodable. And then we put a 3 and a 0. And then we'll do whatever, right? And this one will return 0 because we have this situation which cannot be decoded. It should be 0, right? So that is correct. Otherwise, if we have 1 to 9, then it has to be self, because we cannot combine, right? So these are the situations. Now we're talking about a star. The current value is a star. And it doesn't really matter because we actually check in n minus 1. We're not checking the current value. We're checking n minus 1, and the current value, basically, we just do this all over again, right? So basically, we just say it's going to be 0 to. Hold on. We have to, it's like if the n minus 1, right, is, here's what it is. If we say yeah, let's use this as an example. 1 star, right? 1 star. So n minus 1 is 1, right? So for the star, we say in total, it could be 0. 0, that's going to be 1, right? It can only combine. And if it's 1 to 9, each one we can combine. Combine will give us 1, so add it together is 9. Or we can be self, which is, oh no, it doesn't have 0. It's just 1 to 9. So 1 to 9 is combine ourselves, so that's 18, right? So for if it's 2, combine ourselves both can do is going to be 1, 2, 6. So 1, 2, 3, 4, 5, 6. That's 6, right? So that's 12 plus 7, 8, 9. That's 15, right? And if we do anything that's, say, a 4 star, right? If we do a 4 star, that is going to be 9. This is only 9. And have we considered a situation of the n minus 1 is a star? Have you considered n minus 1 is a star? If n minus 1 is a star, that means the star can be, it's basically says 1 to 9, right? It's 1 to 9. It can be anyone. And we just have to see it through. So we take a look at the situation of 0, 3, 4, 5, 9, plus situation of 1, plus situation of 2, right? Go ahead and do it. Let's do star 4, right? Star 4. If we do star 4, then we say if the star is 0, 3, 4, 5, 9 to 4, so star is going to be 9. So the current is going to be 9, right? So if it's a 4, so it has to be self. If it's a 0, 3 to 9, it has to be self, which means it's going to be 9, right? Self is 9, plus if it's 1, and we have combine and self because it's 4. So it's combine is 9, so 9 plus 2 times 2, and if it's 2, it's also going to be combined. Yep. All right, so that gives us 45. I think that's 45. 2, 4, 5, 45. Oh, I'm way off. Way off. Hold on. Let's see what went wrong. Star. Have to be by itself. Yeah, it's by itself, so that's 9, right? And what if star is 1? Oh, star is 1. That's actually not 9. That's actually not 9. If star is 0, so star represents 0 to, oh, hold on. The values are different. Because star is more than one value. It's like if star is a 0, 3, 4, 5, 6, and then that, it's going to be 1 for each one of them, right? And if star is 1, that's actually only 1. So it's have different situations, right? Which means once we have a star, we branch out. Once we have a star, we have to branch out. Hold on. If we branch out, this doesn't mean like every time we hit a star, we have to branch out. That doesn't sound right to me. All we want is the total number, right? The total number. So if it's a star, we know so 0, 3, 4, 5, 6 to 9, that's what? That's 8 values. Because we plug out 1 and 2, that's 8 values. So for each 8 values, we can get a self, so which is 8, right? Plus, now we're talking about 1, that's a 2, right? So if we're talking about 1, we can do a self, or we can do a combine. So that shall give us 2. If it's 2, we can do a self, or we can do a combine. That's also 2. This gives me 12. That doesn't feel right. That gives me, oh no, there's no 0. There's no 0. It's 1 to 9. It's 1 to 9, so it's 3 to 9. So that's 7. So it's 7 plus 2 plus 2. Oh, that makes sense. That makes sense. Let's try one more. All right, try one more. Let's try star star 4. Right? So the first star give us, doesn't matter what it give us. Does it matter what it give us? Well, if it's a star, it actually does matter what it gives us. If it's a star, we have to consider. So if it's a star, right? If it's a star, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, and each one give us 1. Now we have another star, right? So basically, we have another star. So we look at the previous star, and we have to go through every single situation, right? So if the previous star is 1, right? No, if the previous star is 3 to 9, right? The previous star is 3 to 9. Previous star is 1, right? And my current, so every star is actually going to be 1, 2, and 3 to 9. Actually, no, 1, 2, it's not 3 to 9. It's going to be 1 to 6. Right? 1 to 6 is the same. Yeah, I think 1 to 6. 1. Let's just write it out. That's fine. It's 1 to 9, right? 1 to 9. So current, I'm also going to consider 1 to 9, right? So I say my current value, if it's 1, and my value, 1 to 9, each one will get 2, right? Each one will get 2. Next, previous value is 2. Each one, we're going to get 2 for the first few up until 6, and the rest is going to get 1. Now, previous one is 3, right? Is 3 to 9. Then every one, we're going to add 1, right? Every one, we're going to add 1. So we're going to add 1. It's going to be like this. It's actually not add 1. It's going to be the same as what it has, right? Going to be the same as what it has. So we have to keep going through. So it's like a 10 by 10 in this case to compute a star-star situation, right? A star-star situation. And it's the same for any, right? Any. If the previous is a star, then we have to go through every single one to analyze. Let's give it a shot. Let's give it a shot. I think this is the right way, right approach, but also feel like there could be a lot of, how should I call it? A lot of edge cases. That's the things I'm afraid of. The edge case that might bite me in the backside. Okay, so let's try it. So here we go. Here we go. What are we going to do? So And what's important is, do we have a value in the front? We don't have a value in the front. So we have to analyze, right? So basically, the previous value, we have to have a giant list, 10 to the 5th. That's actually no, because we only, the most we go back is go back once, go back twice, right? We want to go back twice, so I think we only need 2. Right, so the pre, and pre, right? The pre, and pre, that's the only 2 we need. And when we start, we can say PP and P, right? It can be 0 and 0, previous is 0, right? So that's the number. Now the current. The current is going to be interesting. So we're going to say for CH in S, right? The first one. Actually, I think it's fine, right? We're going to say, because we need to look in the previous one. So no. So it has to be I think current need to equal to, right? Current need to equal to something. Let's say equal to 1 if S0 is equal to star. It's not 1, right? If it's a star, then it can be times 9, else it can be 1, right? Then, no, I don't like it. And it's fine. I'm going to say for I in range 1 to len s, right? So we need to compare to the previous one. Okay, now we have current. Current, previous, and previous, yes. So what we're going to do is we're going to check the previous, right? So we're going to say, this is like our logic, right? So we say if S I minus 1, right, is equal to 1, if the previous one is 1, then it's actually pre. I think we need 2 previous ones. Right, we need the 2 previous ones. 1 does not work. 1 does not work. We need 2. And now that's pre. We have a pre, right? We have a pre. That's going to be this. And we have a current, right? And this is going to be a temp, right? We're just talking about this is going to be a temp. No. This is going to be pre. This is going to be PP. It's a pre-pre. It's a pre-pre. So it's going to be PP and pre. And let's call pre-pre. And then we're talking about, this is the current one, right? This is the current one. So we're going to say when we start, say if Si is equal to a star, then current is equal to, what's current equal to? 0 times 9, right? Else it's going to be a 0. Now, if the previous one like si minus 1 is equal to what? 1, right? Then, depending on what we have right now, we say, right? Here's what we say. We say if si is a 0, right? If si is a 0, then current equals to what? Current will equal to combination, right? Combination. That means current gonna equal to pre 0, right? Because no, not pre-0, pre-0. Current equal to pre-0, which now we combine, right? So that's 1. So we have to get a value ahead. Whatever this is a much. So what's the pre then? That's the catnip. So I think the pre should be 1. Like in this case, right? If we have a 0, like a 1, 0, right? 1 is 1, a 0 we say cannot be by itself, so we need to combine with 1. And when we combine with 1, we cannot get everything that 1 can get, right? So 1, 0 becomes an entity. It gets whatever the pre gets, right? So I think when you combine, you look for the ones ahead. I think it's going to be like this, right? Equals, plus equal to actually. So just fine. So we'll just say current 0 equals this if I minus 1, if I minus 2 is larger than 0, right? I minus 2, because that's I, as I minus 1 and I minus 2 is larger than 0, then we can. Else, if we cannot, then just going to be 1. Basically, we're saying there's a 1, 0, right? It can be 1. So that's when si is 0, right? Else, if si is equal to a star. We're gonna do it later. Else, now si is going to be 1 to 9. So we say current 0 and equal to pre 0, right? Pre 0 plus pre 0. So that's combined. That's self, right? Combine and self. If I minus 2 is larger than 0, else is going to be a 1. So I think pre-0 will get added no matter what. So this one can be simplified as else 1, this plus pre-0, right? So basically pre-0, that means the current one is a self, and this one is a combined. So that's what this is. So now we go back to this, right? So basically, because this is going to be 1, so this is going to be, this is 1 to 9, so it's everything here, everything here. So current going to equal to, right? Current going to equal to this times 9, right? This times 9. Actually, let's times, yeah, let's just times 9. So 1 to 9. Because each one, right, each one can be, yeah, each one can be the same amount. Each one can be the same amount. Yeah, each one can be the same amount. Actually, I think it's possible. We just current equals this, right? Current equals this. So that's when this equals 1, right? And if it's a star, we're going to be a list of things, list of different things. Yeah, previous, my current is a star, right? The previous is not a star. So we're just gonna, from 1 to 9, everything is going to be a self and a combination. Elif s I minus 1 is a 2, right? So we do the same, almost the same situation. So we do, if it's a 0, all right, then it's a combination. If it's a star, then a little bit complicated. So we're gonna comment out first. And here we have two situations. So we're gonna say elif si is smaller or equal to 6, but larger or equal to 1, right? If it's this situation, then current can equal to a combination, which is this, or a self. Then else, which is 7, 8, and 9. If it's 7, 8, 9, it can only be self, which means current going to be, if it's self, then what we're going to be is pre-0, right? It's going to be pre-0. Now, here is going to be interesting, right? Because we're going to first say self. 1 to 9, everybody has to be self. So current is going to be self first. So we're going to do self times 9. Afterwards, we're going to say for j in range 7. Actually, I don't even do range. We just say current, well, 7 minus 1, right? 7 minus 1. I just do for j in range 7 to 10. Right, 7, 8, 9. No, not 7, 8, 9. Come on. We're talking about from 1 to 1 to 6. 1 to 6, we need to add a combination. So we say current j minus 1 plus equal to combination. Right? We're going to add a combination to it. So that's that. So the previous can be 1, previous can be 2. Elif previous is a star. We are going to pause right there. Right? We're going to pause right there. And eventually else. Well, what it feels like is we need to like make that into a function, so we don't have to write all these different situations. All right, so like if previous is 0 of 1 and the current is 0, this is what will happen. Previous is 0, current is star, this is what will happen. Right? We'll see. So if I minus 1 is star, right, we have to go through, the current is going to be like this, right? So H1, and then we have 1, 1, 1, 2, 3. So I have to set up a rule. Set up a rule. Anyway, so this, what is this? This is going to be 1. So previous is 1, previous is 2. Oh, I didn't do 0. Let's do 0. Aleph S I minus 1 is a 0. If it's a 0, oh no, it's not a 0. It's right. So here it's 0, 3, 4, 5, 6, 7, 8, 9. Right? If it's this, then we say if Si is equal to 0, right? Then immediately return 0, because there's no point in keep going. Otherwise, if Aleph, no, we just say if Si is equal to star, pass, we'll talk about later, else, right? Else, this is just 1 to 9, right? 1 to 9. Then we say current equals, gonna be self, which means pre-0, right? Gonna be pre-0, because I can only do self. I cannot combine. So from self, it's only 1, and the previous, whatever it is, and extend to me. So here is not going to be passed. So current is going to be, is a 1 to 9, so it's pre-0 times 9, right? So we have one more situation to consider, which is this. So basically, if the previous is a star, right? And we say if the current is a previous is a star, which means it's from 0, from star is 1 to 9, right? So we're talking about 1 to 9, and based on what we are right now, if we are a 0, right, then there are ways, right? If it's 0, then we say 1, 2, 1, 2 can work, but 3, 4, 5, it doesn't work, which means we just combine these two. So we say, yeah, we have to do if Si is 0, right? If Si is 0, then current is going to equal to pre, right? Current, because we have to combine. We have to combine, which means it's only 1 0 or 2 0, right? So it's actually pre-pre. What if pre-pre is a star? Pre-pre can be a star. Yeah, pre-pre can be a star. What if pre-pre is a star? So what you're saying is it's like a star 0, right? Star 0. So star we have 1 to 9, and it's a 0. So we say 1 0 2 0. That's good, but all the others don't do. So we're gonna combine 1 0 2 0, and then from 1 0 2 0 we have to look into the pre-pre and see what it is, which means its current is 1, right? Then the pre-pre, then a pre. Just in one, it's both. We have combine and we have self. Now I have combine and self. It's combined together. And now we say 1, 0 has to be combined. But that's basically just 1. So we need to look at the pre for all the ones. Now it depends, right? It depends. Yes, it does depend. So we're gonna say if I minus 2 is larger than 0, right? If I minus 2 is larger than 0, if not, then it's just going to be 2, right? If not, then just going to be 2, which means we're talking about star is 0. This is star 0, so it's just going to be 1 or 2, right? 1 or 2, that's only 2. So that's that. So when I minus 2 is larger than 0, then we have to further, right? We'll have to put parentheses. Then we have to check to see if, right, if si minus 2 is a star, right? If it's a star, then we need to add them together. If it's not a star, then we basically just add that directly. If it's a star, that means we need to add everything, right? So else, I think just pre 0, right? If it's not a star, it's going to be that. If it is a star, then it's going to be sum pre, right? It's going to be sum if it's a star, right? If it's a star, hold on. If it's a star, then we have 1 to 9, and everything has something. We're going to add them together, right? And I say current is 1, and we're not combining, which is like whatever the previous one is, and then I'm just attaching myself to it. So basically, this has to times 2. This has to times 2. And this is going to be 1. And we're going to do the entire thing, right? The entire thing. So sum this, if this, else this, if this. So the entire thing. Right, we're talking about the entire thing times 2, because we have 2. So that's when si is 0, right? Aleph si. Now we're going to do if si is, oh, it's very complicated. If si is 1, man, this is a lot of logic. Like, if I is 1, I is 2, I is 3, I is 4. Each one is slightly different. Maybe. You know what? We shall do everything, and then we pick whatever we want. Right? Yeah, I think that's the right way to go. We just do everything. So it's 1, right? And then we should yeah, we should literally just do a temp, right? Let's say temp is 0 times 10, right? And then if we shall fill it up, right? We shall fill it up with each different one. Let's say for j in range 10, if si equals fj, no, j equals 0, then we do temp j equals this times 2, right? Aleph j is 1. And we don't have to do, we just temp is this, right? And temp 0 going to be this, temp 1, right? Temp 1 is going to be previous is star. Now temp is 1, right? So I am 1, and previous is from 1 to 9, right? 1 to 9. So every single one, previous is 1, and 2 is going to be combination itself, right? So we have to say combination and self. So we'll say combination is pre-0 if I minus 2 larger than 0, else 1. This is a combination, right? So that's combination plus self. That's pre-0, right? So combination, but again, it happens to every single one with a pre-pre. Pre-pre can be a star. No, this is not the way to go. This is not the way to go. The pre-pre can be star. You have to change every single one. Hold on. No, let's do this, right? So what we talking about? We have the current, right? Current value, and we have the previous value, and we have the pre-pre value. So we have 3 that we need to consider. So we say if current value is 0, right, based on the previous value and the pre-pre value, we get a current value for 0, and we get current value for 1, 2, 3, 4, 5, all the way to 9. So we get 10 of them, and then based on what? No, I want to redo this. This just looks so complicated. So complicated. Here's what I want. Right. This is correct. This is correct. Right? Pre and pre-pre is correct. What I want is not this. No. I want to redo it. I want to do a temp equals 0 times 10. Right? And I say temp 0. Right? That is to consider my current value is 0. Right? Current value is 0. If my current value is 0, then I need to look into my previous value, right? So look at my previous value, right? And if I have a previous value, then it also depends on what my previous value is, right? If my previous value is something that if my previous value is so previous value could be 0, could be 1, 2, 3, 4, 5, 6, 7, and 9, right? It could be any of those, or my previous value can be a star, right? It can be any of these. Hold on, how do I summarize the situation? So I have my current value, I have my previous value. So the previous value, I can say if previous value is 0, then it's bust. Previous value is 1, we get a value of 2, we get a value of 3, get a value of 4, 5, 6, we all get a value. And previous value can also be a star. Then that would just be the addition of 1 and 2, right? Yep. So temp 0 is going to be the previous value of 0, right? So previous value is 0. Now we just don't consider, right? We just like we try to see what we can get. That's what we try to see what we get. Like what we can get for temp is 0, right? Temp 0. Pass 0 in, now we compute, right? Maybe we need to define a new function. Let's call it compute. We need a current number value. We need a pre and a pre, and we also need s. So we have I, and I want to need I then. I and s, right? Actually, yes, that's what we want, right? And then now we're going to compute something. So we don't care, right? We have to have n. N is just a value, right? So it passes 0 in, so we say if n is 0, right? And then if n is 0, n is 0, then we say based on what we have, right? So we say, I should put this one inside as well. Now what's the difference between putting here, putting here? Separate concern. But compute is just compute what the current is, right? What the current is. No. What I want to compute is, given value n, and current is I have a pre and a pre-pre and s. What's like this current value is not a real value. It's just a hypothetical value, right? It's hypothetical value. Given a current, hold on. What we're trying to say is given a current value, and we have previous values, right? What are all the possible values? And current value can be like this as well, right? And this is a 10 by 10 matrix. And for each combination, we can figure out, right? We can figure out, and we say if pre, yeah, and put it in, and we compute, right? So we can compute a matrix, then based on what we have, right? If my current is this, my previous is this, then but we also have the pre, right? We have to go pre as well, because it affects. Like if it's a combine, then it basically have to ask pre. Okay, well, if it's a combine, why do we have to ask pre? Like what it is? Doesn't matter, right? It doesn't matter. It's just the total. It's just the total value. And if it's a star will have a total value as well, right? It will have a total value as well. Yeah, it doesn't really matter. It doesn't really matter. So just the pre. It's just if the pre is a star, we have to sum it up, right? We just have to sum it up. Yeah. Okay. So again, they're saying if I am 0, right? If I am 0, what am I gonna get? If I am not, if I'm 1, what am I gonna get? If I'm 2, what am I gonna get? Right? So basically, we say if n is 0, right? If n is 0, if n is a 0, its current is a 0, then what I'm going to get is a different, right? If the previous is a 1 or 2, right? Then we're going to combine, we get pre. If previous is not, then we get, yeah, if it's a 0, I get a value. Yeah, I think we just do if Si is a 0, right? If Si is a 0, then we're going to say if Si minus 1 is a current is a 0, all right? If minus 1 is a 0, if I minus current minus 1 is not in 1, 2, or star, then we return 0, because there's no way. Right? Otherwise, if it's 1 or if it's a 2, right, then we just combine and say if Si minus 1 equal to star, we'll discuss this later, and Aleph, right, Aleph is a 1 or 2, then we say combine. So what we need is if I minus 2 is larger than 0, else it's going to be 1, right? Else it's going to be 1. If it's larger than 0, then we actually say current, right, equals to this. If it's not, then what we're going to do is pre 0 if si minus 2 is equal to a star. Else, if it's not a star, then it's pre-0. And this is not pre-0, this is going to be sum pre-. So it's going to be, current is going to be this. If I minus 2 is larger than 0, so we have a pre-, then when you check this, if it's a star, we're going to add them together. We add pre together, right? We add pre together. If it's not a star, then we just go pre-0, right? With the pre-0. And this is make it into a, so that's the situation of 0. And now we're saying if the previous is a star, right? If the previous is a star, then we have something to talk about. If the previous is a star, then we basically pick only 1 or 2, right? So what we're saying is whatever we compute here, right? Whatever we compute here, this thing, right? This thing. So we're going to say current equals whatever we compute here. That's for either 1 or 2, and then multiply by 2. So that's the 0 situation, right? Now, if si is equal to 1, if I am equal to 1 or 2 or 3, 4, 5, 6, 6. So if I'm equal to 1, 2, 6, which means I think these are all the same situations. So if I'm going here, 1, 2, 6, right? If I'm a 1, 2, 6, then I fall into the category of combined self, right? So again, we're going to look if si minus 1, right? If I minus 1, because I'm 1 to 6, so the previous one I can take 1, but I can take 2. I cannot take 0. Well, I can take, and we're talking about self first, right? So self. So self and combine. So there are 2 different parts. So we say for self, right? I'm going to say for self. So this one, let's say for self. If for self, no combine, then it doesn't really matter what it is previous, because I can always be myself. That's not true. That is true. 1 to 6, I can always be myself, right? I can always be myself. It's 7 to 9, they can only do self, they cannot do combine, right? So 1 to 6, I can do self, right? So if I do self, which is myself, right now, myself, then I'm going to add whatever just in front of me, right? Just extension. I want to do an extension. So when we do extension, it depends, right? No, it does not depend. It's just if the previous one is a star. Again, we're gonna pass on this for now. Else, right? The previous is not a star, right? Then we're gonna get whatever it has, right? Whatever it has, can extend to me. So when I say current equals whatever the previous one has, so pre-0, right? Whatever the previous one have, I am willing to take it. Now, if previous one is a star, that is a different situation. Then what we need to do is current equals to, we have to sum pre. So whatever the pre has from 1 to 9, right? We just sum them together, right? Sum them together. So that's when the previous, if it's a star, then we do this. If the previous is not a star, then we go through all of them, right? We go through all of them. Whatever the previous one is, we just grab it, right? We just grab it, because I am self. Now, for combine. Now for combine, we have requirements. Because I'm 1 to 6, I can combine with 1 and combine with 2. That's the only two I can combine. Right? Only two I can combine. And of course, the next one will be 7 to 9. I can't combine with 1. So I combine with 2 things, right? So we're going to say that only happen if Si minus 1 is in 1, 2, or star. Right? That's the only situation that can happen. If I minus 1 is 0, no combine. 3, 4, 5, no combine. So the only combination possible is 1, 2, or star. So when we do that, right, then we have to check if it's actually going to be this, right? And then we do blah blah blah, we do pass, and Aleph is I minus 1 is equal to star. Then we do a blah blah blah. Otherwise, we don't do anything else. Right? So right now, at this moment, we have the pre is 1 or 2, and we want to combine. So we have to do pre-pre, right? Pre-pre. So what we have is if I minus 1 and minus 2 is larger than 0, otherwise it's going to be 1, right? Otherwise, combine is going to be 1, right? So otherwise in the pre-pre 0, right? But there's also a complication, right? Pre-pre 0 is if Si minus 2 is equal to star. Otherwise, it's going to be this. Then we have to say sum pre-pre. See, this is the same pattern, right? This is the same pattern. The same pattern. So this is a combine, right? So this is a combine is larger than 0, larger equal to 0, then we do 1, right? If it's not, then we say 1, right? If it's not, then we have a pre-pre. And then if this one is a star, then if it's a star, then we say we don't have pre-pre. Our pre-pre is going to be a giant list. So we're going to sum them together, right? All of them together, because they all work. Otherwise, it's pre-pre. So, and this is going to be current 0 plus equal to, right? Plus equal to this, because we already set it up, right? We set it up here, and this is a combination. We add more. Now, if the previous one is a star, right? That means for combination, we need to do 1 and 2. So we're going to take this, right? Take this whole thing, and we say current 0 plus equal to, take this whole thing times 2, right? Because we can do 1, we can do 2. So those are 2 for combination. Done, right? Aleph, right? Aleph 7 smaller equal to Si, smaller equal to 9. Right now we do 7 to 9. 7 to 9 only self. Only self. We cannot combine, no matter what. We cannot combine. Now, if we cannot combine, no, we can combine. We can only combine with 1. We cannot combine with other things. So for self, no combine. I think it's the same code, right? It's going to be the same thing. Same logic. And then for combine, it's also the same logic, almost the same logic. So for combine, right, if this is 1, it's actually, it doesn't matter if I have 7 to 9, right, 7, 8, 9, even if previous is a star, right, even if my previous is a star, it's going to be the same. Because I cannot combine with 0, I cannot combine with 3, 4, 5, or everything else. I can only combine with 1. I cannot combine with 2. So it's the same. So for combine, it's actually the same. So if in this or star, right? If the previous is 1 or star, then I can combine. But I can only combine with one thing, which is whatever this thing is, right? This is what I can combine with. Last but not least, so this is a star. So my current is a star. Now we're talking about something complicated. If my current is a star, right? If my current is a star, which means I have to go through the entire thing here, right? The entire thing here. And I want to simplify it by making it a function call. I mean, I shouldn't say make it a function call. What I can do, right? What I can do is, because I already computed, well, actually I did not compute this. It's only like when this happens, then I compute this. I just don't want to repeat the entire code. Well. I don't want to repeat the entire code. Basically, it's like if it's a star, then I have to go this, and this, and this again, right? We have to do this entire thing, right? I have to do this entire thing, which means if I can make all these a function call, right? What type of function call it is? It's like different situations, right? Different situations. So what we're gonna say? Let's say compute C0, right? C0 is going to be, what do we need? We need I, right? C0 we need I. We need 3, yeah. And we'll put this one inside C0. So this is C0. Now this one should be outside. This is an edge case. So C0. I guarantee that I-1 is not this, because we call this one first, right? That's C0. With this, then we return, right? We return this. Else, we're going to return this times 2, which means what we can do, we just compute. We can say compute, so def combine. What do we need for combine? We need pre I and S. So pre I and S. This is what we need for combine. And this is this thing. Right? So we can just return this. Some pre if this equals this, else this, if this, else this. So that's combine, right? So everyone need to have self. Everyone need to have self. So I'm going to say com equals self, right? Dot combine pre is, and if it's going to be this, that's just going to be, so we can return com times 2, right? I'm going to say return com times 2 if this is this, else. Let's return integers. Let's return integers. It's no point. Yeah, let's just return. Oh, there's no point. The only thing that's not going to return integer is if the current value is a star. Everything else is going to be integers. So I just return integers. So we just return combination times 2 if the previous one is a star, else just right? It's combination. And that's the first equation, which we're going to use here, right? If it's not in this and otherwise, yes. Otherwise, we are going to, hold on, I need to move my screen. All right, I just need to adjust my screen. I think we're good now. All right, so where are we? Here. We say if it's this, otherwise current is going to equal to, we put this one here, self dot c0 count to 0. We have I pre s, right? That's that. Aleph is this. So this is going to be, what should we call it? Self. Yeah, so we have a combination, right? We also can say def self. There's no combination. Let's call it no combine. No combine. So self is like a keyword. No combine, we just need pre and I and s, right? So this one integer as well. So non-combine is this thing. As you see, these two are exactly the same. So we're going to do this, and we say return sum pre if the previous one is this, else just pre 0. Return, right? That's no combine, which means in here we just say current equals self dot no combine pre I s, right? And I don't even need this comment because the function name is a comment itself. And then we need to combine, right? So when we combine, let's see. So when we combine, this part is already done, right? So we just say if this is going to be, so we're going to say the same thing. Comb. I feel like this one should be here, right? This one should be here. So def c 1 to 6, right? 1 to 6. Let's say 1 to 6. I just see C0, we can combine them together. Come on, we can do that. We can do that, right? We can do that. Yeah, we can do that. So what we just say is, okay, let's do an n. Oh, we have I. That's fine. That's fine. Hold on. What's our goal, right? We want is we pass a value in, and then I can just call it, right? I can just call it. So basically just have three different situations. A 0, right? A 0. It's actually not really that different. Combine times 2. It's the same. It's the same combine, right? So there's a current value and we want to combine. If you look at it, this is the same thing. Combine the same thing, right? Hold on. Let me think. We get a combine, right? And then we say a combine times 2. And here is the same thing. Okay. I minus 1 is in 1 and 2. Then we do combine. Combine with 1, combine with 2. And 0 is the same thing. Combine with 1, combine. That's the only thing we can combine with, right? It's the same thing. So we can do this, and we just say, given n, right? Say if n, give it ch, right? We just say if ch is equal to 0, then we return this. And we can just call it compute, right? If ch is in, no, if ch is, let's say, 1, smaller equal to ch smaller equal to 6, right? If it's this, then, right, then we're going to return then I'm going to say temp equals this, no combine. So we have no combine first, right? So we have here no combine, and when I say if plus, so basically it's going to be self dot no combine plus something, right? Going to be plus dot combine, self dot combine. No, we already compute. It's called comb. So combine if si minus 1 is in 1 and 2, right? Oh, we also have a no combine condition. Okay, so that's not the best way to do it. So the best way is here, right? If it's this, return. So we can just say combine, no combine equals, so we're going to reuse this, right? So combine, no combine. If it's this, right? If previous is this, then we return no combine plus combine, right? Just put these two together. Elif si minus 1 is equal to a star. Return. Right? If it's a star, then we return no combine plus combine times 2, because we have to consider two situations. And else, everybody else will just return no combine. Right? If 7 smaller equal to character smaller equal to 9. Again, for self no combine, we're gonna do that's no combine. We have the no combine, right? So with no combine, we get the no combine already. So just for combine, right? For combine, we just say if si minus 1 is in either 1 or star, right? Then we're gonna return no combine plus combine, and the combine is only combine 1, right? No combine and then combine. Else, everything else, right? Everything else is previous one is not 1s, not star. Then we just return no combine, right? We just return no combine. So that is the function, which we can simplify to say current equals self dot compute, not no combine, self dot compute. We need si, which is 0. Just put it back in. I, pre, and s. If it's this, right, we say current equal to well, actually, we can just do si, right? And this is actually also si, because we do the here, right? So I think what we need to is just say this is the special occasion. If equals to 0 and this and yeah, I think it can do this if 0 and this is not in. So that's the special occasion, right? And then if si is going to equal to a star, right? That is a special occasion, right? That's a special occasion. And else current is going to equal to this. So I don't need all this, right? Current is going to be compute whatever the current is, and yeah, do that. Now, when it's this, what we're going to say is for j in range 1 to 10, right? Current equals to this, right? I'm going to say self.compute this, and then this is going to be strj, right? strj, and it'll be easier, right? I don't have to turn strj. This can be just values. Yeah, they just can be values, but let's just do all str. That's fine. So it will be strj, I believe is pre, and s. Right? Yeah, let's put in one line. Right, so current, if it's this, and if it's this, current can be this, otherwise current can be this. Now once we're done, get a current, then we need to say pre, and pre equals pre and current, right? So pre gonna be equal to pre, and then pre gonna equal to current. And we go to the end, right? We go to the end. Now, what do we return? Well, we're gonna return this. If it's the last one coming in, and we have the current, so the pre. So return sum pre. All right. Let's check, see if this one's correct. If this one's not correct, 1 hour, 1 hour and a half. So we're gonna go for the answer. But so far, we're gonna try 9, right? And 1 star is going to be 18. 2 star is going to be 15. I think I also have a couple here. We know star 4 is going to be 11, right? And star 4 is 11. Star 4. I forgot what's star 4. 114. All right, that's the challenge. Star 4. 114. And always remember we need to mod 1, 2, 3, 4, 5, 6, 7, 8, 9. So, oh, that's what we're gonna mod. All right, we have to mod 10 to the 9th plus 7. Okay, 2, 3, 4, 5, 6, 7, 8. No, I'm too much. Right? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, so these are our starting position. And of course, let's do like 3, 0, right? This is gonna be 0. A bunch of this, no def C, and S answer. This is going to be, what's the question? Num decoding. Try it. We pass most, but we fail on test case 4, which is, it is indeed, I think, the most complicated one when we have this. All right. So, why do we fail? Let's write it out. So again, what we have is first star, which is given here, right? And when we're given here, 1 to 9, 1 to 9, 1 to 10, that's like 9, right? 1, 2, 3, 4, 5. That's 9, it's a 9. So the pre is going to be 9, because it can represent 1 to 9. That's fine, so the pre is going to be, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now, the second one coming in, all right? The second one coming in. I want to compute, all right? I want to compute. So, I want to compute is, we have a new array. Now we say it's going to be 1, right? 1 coming in. So, current compute is 1. 1 falling here, right? And then we say the previous one. The previous one is a star, right? The previous one is a star. So we say it's going to be no combination plus combination times 2. Plus combination times 2. So no combination is going to be, what is no combination? No combination is, no combination is here. So if I minus 1 is a star, which is, I minus 1 is a star. So in the sum pre, so pre is going to be 9, right? 9. So that means 1 coming in, right? 1 coming in, 9 is non-combination, which is just self, me by myself, right? Me by myself. Okay, me by myself, then it's just all the combination previously plus me, right? That's correct. And then that's no combination. Now we have to do the combination. Combination is say me combined with something previous. And I can combine one, or I can combine two, right? So we say we're gonna plus combine times two, right? So combine is equal to this. So we have to go here. And I minus 2 is minus 1. So it has to be 1, right? Because I am 1. I want to combine with the previous one. After I combine, it's 11 and 21, right? That's the result of combine, 11 and 21. And that's just 2 more, right? 2 more. So I say plus 2, right? Plus 2. So that gives us 11. 11, which we can actually check, right? We can actually check. What we're trying to say is star 1, right? Star 1, oh, settings. Star 1 is 11. Yes, star 1 is 11. Now, star 2 is 11 as well, right? Star 2 is 11 as well. Star 3, 4, 5, all the way to star 6. They shall all be 11. Yeah. So we're going to have 11, right? So 1, 2, 3, 4, 5, 6. All of them are 11. Now 7. 7, we fall into this. 7 is going to be, well, we can only combine with one of them, which is 1. So 10. 7 is 10. 7, 8, 9, they're all 10. That's correct. So 7, 8, 9, they're all 10. Yeah. That is correct. So after the first, we can actually print out, right? So what we're going to print out is, at the end, I just print pre and print pre. Right? At the end, pre is all ones, pre is 11, 10, 10, 10. That is correct. And then I go back up, right? I go back up. Now I go back up. We have 4, right? We have 4. So 4 comes in. It's not this. It's not this. So the current is just going to be 4. All right? 4. I think the current is not correct. Hold on. Let's see. Maybe we did this one wrong. Oh, it shouldn't be. Pre and pre. Pre equals the current pre. And then pre equals the current. And print it out. And then I go one more time. Right? One more time. So let's also say SI. Let's kind of see. Did we do? Yeah, it's a star. And then we do this. Oh yeah, we come out as 98. Hold on. What is our combined? So now we have 4, right? 4 comes in. 4 comes in, and I'm gonna compute 4. It's gonna be here. So we're gonna do combine and no combine. Combine, right? If we want to combine, then if we want to combine, what is the combine? Combine, 4 can combine with everyone previously. So When it say now I minus 2 is not larger than 0 now. It is 0, so we can go here, right? And this is a star, right? This is a star. So what we're gonna do is we're gonna take the pre-pre, all right? The pre-pre. What is the pre-pre? The pre-pre is this one, right? This is the pre-pre. Hold on. What I'm saying is for each one, right? So if I think it's the problem with the combine, because no combine is correct. No combine, we just sum up the pre and we're done, right? If no combine, we just by myself, right? And then we just sum up the pre. If it's combine, then I need to combine with a 1, right? I need to combine with 1. I need to combine with 2, right? I need to combine with those 2. Hold a sec. So 4, that's after, right? So this is the, so pre is this, pre is this. Now 4 comes in, right? And then my previous one is this. So when I want to combine, right? When I want to combine, if this one is nothing, I guess it's just going to be combine. So I am here, and I want to combine. All right. So if it's this 1 or 2, then I combine with what I can combine, right? I can combine. That means I'm looking at the previous one. Yes. If this is a star, right, that means at the 1 position I have 11 different. Right, I have 11 different situations, right, for the 1, right, for the 1. But that doesn't matter. The 11 does not matter, right? Because that 11 is the total number of decoding at that position. It's the total number of decoding at that position. But now we're saying we don't care about the total number of decoding. I just want to combine with you, become 1, 4, right? If I am 1, 4, what is the total number of decoding? That is directly correlated with the ones ahead of me, right? Which is sum of pre-pre, which is 9 different ways. Yeah, that's correct, 9 different ways. So I shall have 9 different ways for the combine of 4, right? For the combine. So I should have 9 ways, right, to combine. And if it's 2, we also have 9 ways to combine. So the combine is combine times 2. Right? And now self is going to be the sum of this, which is 1, 2, 3, 4, 5, 6, 66 plus 30 plus. Wait, hold on. 1, 2, 3, 4, 5, 6. Yeah, 66 plus 30. That should give us 96 plus 18. That's 114. Something is not right. Something is not right. Wow, look wonderful. Hold on. If this, it should be no combination with some pre, right? Else it take pre 0, and the pre is this, right? How is it we get 98? Hold on, this is not right. This is not right. Let's see. No combination is, yeah, it's I minus 1, and I will use some pre, right? Some pre is already 96. Hold on. Let's print character. No, if character equals, no, if I equals 0, 0, 1, 2. If I equals 2, right? Then we're gonna print this, yeah. I want to print combination, and I want to print no combination. All right, let's go. 96 is correct. What is wrong is combination is wrong. If this is larger or equal to, I think that is where the bug is. Okay, so now we can try it again. Now we pass and do the other things. See if all the other things. Oh, we all pass. Oh, do we dare? Do we dare? Try it. All right, let's do this. Oh, nervous. We can run a few more test cases actually if you want to. I think, for instance, we can just smash some screen, right, with some numbers, and just run code and see if this one comes out as we expected. It does come out as we expected. So let's try it. Go. Pending. Judging. Ooh, does not look promising. Might be a wrong answer. Might be timing out. Oh. What is this? 0. Huh? Edge case. Edge case. Output 1. Expected 0. I think it's here. If this is 0, oh, the pre. If this is 0, else. It should be 0. So if this is this, else. Else this, else 1 is 0. If is 0 is equal to 0, else this. So if we go 0, that is going to give us 0. There we go. Did we pass any test cases? Don't tell me this is the first one. We passed 186 out of 217. So this is definitely promising. Okay, so we fixed the edge case. Now let's try again. Submit. I wish I should try a few more. It doesn't matter. Alright, I might have another error because it kept judging. If it kept judging, I mean something's wrong, or we TLE. We TLE. How is that possible? How is that possible? How is that possible? Well. Let's see. I mean, it's just because. Why? I don't like it. I don't like it. Because of sum? These are all 1. Sum is 09. We consider that 01 as well. I mean, the only thing that is here, right? I mean, I agree we have a loop here. We do have a loop here. I think maybe because we're using the using this. I don't know. We timed out. Don't know how to improve. If this will return to 0, and the pattern is just, dear God, look at the pattern. That means every 1 will get 1, and then we do this with a star, and we have to compute every single one. I mean, that's true, and we don't have to compute every single one because there are only 2 values if you think about it, right? There are only 2 values if you think about it. So, in that case, right? In that case, we're gonna say, yeah, we're gonna be smarter. We're gonna be smarter. Let's just say we have 2 values, all right? So we say part 1 is going to be self to compute this, right? Doesn't matter, we're going to just do 1, right? Self to compute this, we're going to do 1. Part 2 equals self to compute this, we're going to do 7, right? So we call the function twice instead of call it 9 times, right? And then what we're going to do is say current is going to be equal to, let's call it P1 and P2, right? P1, P2. So we say P1 times 6 plus P2 times 3. So we eliminate this. Run it, I'll pass. See if we have better luck. I mean, the first check we can do is by running this gigantic thing and see if we time out. Oh, it's slow. 3,000 milliseconds. Oh yeah, let's pass. Come on, let's do this. Pending, judging, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000. Oh my God. Oh, we did improve. We did improve. Oh my goodness, look at this. All right. All right. There's another trick up my sleeve. It could be a large, like giant value addition. It could be slow. So another thing we can do is I'll actually try how long does it take to run this gigantic string. Oh man, it's so huge. It's probably time out by itself. All right, let's try it. So what I'm gonna do is def initiate self. Doesn't have anything. So we say self.mod equals 10, 9 plus 7, right? And then what we're gonna do is sum this if this else 1. So we're gonna return this entire thing, all right? This entire thing mod self.mod, all right? So we're gonna mod at every single opportunity. So we don't let this self.mod. And then this is it, they're all mod, and then return this mod actually we can do even better. We can say res equals 0, right? And then let's just say res equals this. Let's come, let me do this. Actually, we're gonna do this. And then if this res equals else res equals else res equals else res equals, and then it had to be elif. Right, elif elif, and we will not pass in if it's a star. Yeah, so elif res equals this. Right now at the end we return res. So we do have to have a res at the beginning, otherwise I don't think it's going to be error. If this if this if this is this, you can call else, because we know the current character I'm not going to pass in. Yeah, I can say it. So if this is going to be else, right? Else, and we're going to just put this in a comment. Then we're going to return else mod self.mod, right? So every single step is going to be mod, right? And then this is going to be.
I don't pause the phone sync.
Yeah, it's fine. Yeah, it's fine. I do that in last time. Yeah, some of my pasta fell last week. Regular the cheat day cooking. All right, so with this, come on, show me your chivalry. Oh, look at that! Look at that! That is the problem. Now we finish at 280 milliseconds. So the problem is we need to mod at every single chance. I think that is the problem. Submit. I have high hope. Pending. Judging. Boom! Ow. I just made this too hard. I hurt my finger. We got it. Wow. 2 hours of very, very intensive coding. Oh man, my finger hurts. I shouldn't do that. But oh, I'm happy. I'm happy. This is not slow. Not slow at all. Okay, it's pretty slow. 25%. I don't care. I do not care a single bit. We solved this. This is a hard question for sure, and we solved it. Oh man, it's actually think about it's not that bad. It's not that bad. Okay, so how do we summarize this? It's dynamic programming. This is dynamic programming. This is DP, but with it's pretty intricate. Yeah, I won't say it's like difficult. It's intricate or complicated logic. We keep track on the total number of decoding possible for possible at with the given string at each ending at each index. Then we compute the number of decoding for the next digit. The complicated part is when the previous digit is a star, right? Or the pre digit is a star. For a digit, there is only one answer for the total number of decoding. For a star, we need to record the answers. Just realized we can't make it even faster because we don't need to record the answer for we don't need to record the answer for 1 to 6, right? So we need to record the answer for 0, record the answer for 1 to 6, and record the answer for 7 to 9. That's the only 3 we need to record. So I think we can be faster. We can be faster. Maybe just slightly faster by modifying a few things. Like we don't have to modify any of these. That's the beauty of the algorithm. We don't have to modify any of these, just the implementation. So instead of say 9, right? Let's say we do 3. We do 3, right? And then this doesn't change. This does not change. Does not change. Only change is here, right? So if it's 1, then we do this. And we do 1, we do 7. So that's just the 2 situations, right? The 2 situations. And do we even need 0? Oh, wait, there's no 0. There is no 0. My brother, there's no 0. That is the 1, which we can simplify by calling this, right? Let's make it look nicer. And this, I'm gonna call 7. And run it. Ugh, that is not correct. Of course it's not correct because we're doing a sum. Now we should not do a sum. We don't do a sum. No, we do not do a sum. It's only 2 values, right? So it's not sum. It is pre 0 times 6 plus pre 1 times 3. Whenever we do sum, this is what we're talking about. And I actually want to rewrite this. This is just unreadable. Alright, this is unreadable. Let's just say if I minus 2 is smaller than 0, then return 1. else, right? Else we say if this, readability is king. If this, I'm going to return we're going to return this, right? I'm going to return this mod self.mod, right? Else we're going to return pre-0, right? So that's the combine. No combine, right? No combine. We say if si minus 1, right, is equal to star, then return same thing, but it's not pre-pre. It's just, oh shoot, it's just pre, right? We'll return pre. Otherwise, we'll return pre-0, right? And then none of the other chains. Try it. Oh, we still missing the first one. Let's see. It is not 3, it is 2. Okay. Let's see. Oh, what got wrong? If it's I, no combination and combination. 0 times 6. Maybe they're different. No, they're not different. They're the same. They are the same. So why would it be 2? That's the problem. If it's a star, right? Oh, it's a sum. Ah, I see. So what's going to be is sum this if len sum, len pre is 1, else going to be pre 0 times 6 plus pre 1 times 3. And we put everything in a giant parentheses, and that's not sum pre. Right? That's just going to be pre 1, pre 0. Right? Pre 0. Now we pass. This one might be faster. Let's keep right forward. We need to record 2 answers. Right? It's only 2 answers. Record 2 answers. One is for digits 1 to 6, and the other 7 to 9. Alright, for digit, for that we need to record 2 answers. And when a previous character is a star, we have to consider the outcome of all 9 digits, right? The outcome of all 9 digits. Now, let's add that, and then for each digit, we can either make it by itself, encode, decode it, either decode it by itself, right? By itself, which means the total number of decoding is equal to pre, right? Equal to the total decoding of the previous character. We can also, or we can decode it by combination with the previous char, if and only if the previous char is 1 or 2. And then we need to look for the total number of decoding with the previous char. Yeah. And that's it. I mean, when if the current char is star, right? We basically have to do. We basically have to do. Have to go through 1 to 9. However, 1 to 6 gives the same answer, and the same answer because they can both be self and combine. And 7 to 9 also gives the same answer because they both be self and combine with both 1 and 2 because they can both be self and combine with 1. Continue with this logic until the end. We have the answer, and we have the answer. In the last, we have the answer, and we have the answer. Okay, so, oh, and one more trick. Keep modular throughout the algorithm. This significantly reduces time. Because most likely because arithmetic of gigantic number is very slow. Okay, so we have a new version, and it passed everything that I throw at it, right? And now let's see if this one will be faster. Okay, so let's try this. I think previous record is 200 something, right? Pretty much the same. Yeah, I think it's the same. Yeah, it's probably much the same. That's slightly faster. 800, 740. Yeah, that's a record 740. Yeah, I don't want to know the runtime. I don't know the runtime. Oh, I know the runtime. Runtime is ON. Runtime is ON because everyone is O1. This is O1. These are O1. Everyone is O1. So ON runtime, and we have 714 milliseconds. Give us a 33% ranking. I am happy with 33. All right, now let's go for it. Oh, yeah, 2 hours. 2 hours. That sounds about right. Please be difficult. Yeah, a lot of people don't like it. After Adam Mize, 745 thumbs up, 662. Thumbs down. I don't know why. This is all right. What's the topic? Dynamic programming. Yeah. All right. All right. So first, let's look at the comments. Frequently asked questions, please. Super problem. Oh, wait. What is the rank number 639? I don't know. People are asking why mod this. I mean, because it's too big. Given solutions are failing for test cases. DP, lots of DP. People complaining test case is broken. 16 ways. No, it is 15. On the second chapter, yours, yes. It cannot be 0. They probably changed. They changed the question, I'm pretty sure. Yeah. Oh no, this is only represent. Yeah, that's just didn't read the question carefully. Oh, this is a bug, right?
Mm-hmm.
I fixed the code. Wow, we're talking about people discussed in 2017. 2017. All right, let's see. Oh my God, look at the code. So short. So short. I mean, mine is not that long. Yeah, it is pretty long. I split up, that's why. I mean, if you think about it, these two can, I don't have to write these two. These two can be together. Anyway. Constant space. I am constant space dynamic programming. This is constant space. We have, that's it, tree and current, right? It's constant space. All right, let's just see. Recursion. Drink some water. Find a solution we need to consider. We have a function ways. It returns the number of ways to decode the input string s if only the characters up to the ith index in the string are considered. We start by calling the function this. We started by using the last index of the string s. Suppose currently we call the function as si. Let's look at how we proceed. At every step, we need to look at the current character at the last I, and we need to determine the number of ways of decoding that using the ith character. Could add the total value. There are the following possibilities. If ith could be this, in this case, first we can see that this could be anywhere 1 to 9. That's for every decoding possible up to index. And then this could be replaced by any of this. The total number of decoding is 9 times the number of decoding possible for the same string up to this. Thus, that's correct. Apart from this ith could also contribute further to the total number of ways depending upon character that's preceding. That's correct. If the preceding happens to be a 1, by combining yes, which could be decoded into any of the characters, so we need to know that these decodings are in addition to the ones on a current. Thus, this 1 star pair could be replaced by any of the numbers irrespective of the decoding. Thus, this I could have to do 9 times ways. That's true. And if it's 2, that's going to be 6 times. That's true. if the character at that happens to be another star, this could be considered as any of the numbers. This and this, thus the total number of decoding will be 15 times the number of decoding at -2. Thus, if I copy a digit from this one as well, in this case, yeah, I think it's the exact same way of doing things. Right? The exact same way of doing things. It's just, like I said, I think, yeah, ON. It's not difficult in terms of trying to be like smart or anything. It is, yeah, it's complex, but not complicated, right? So it's intricate, right? It's complex. It's a complex problem, but it's not complicated. It's not. There's no trick in it. You just have to analyze every single situation. And once you done analyze everything, it's pretty straightforward. And there are a few speed up you can do, but it is difficult because like for me, in my case, to write something that's not gibberish, right? Like this, to me, is gibberish. Hard to understand. Lots of if and else, all thrown together. Even like dynamic programming is the same. Like just see this, you see this code, and you just immediately scratching your head. I say, I don't want to read this. But what I hope is this version is clearer because we have documentation, right? Basically by using different functions and give us documentation. Like combine, we know, oh, this function is say we want to combine the current with the previous, and this is what we're going to get, right? And then we say no combine. And then when we compute, we get a combine, no combine, and based on what situation we are at, we're going to return whatever value we're going to get. So we might call this too many times though, because it's necessary. Plus, we need to do this. And then the main function is also clear. We have the first one, and each one we have the edge case checking here. We forgot the edge case here actually earlier, and we say if it's a star, then we know what we want to do, and if it's not, it's going to be this swap. Yeah. All right, that's it. That's it. I don't think it's necessary to read through everything. We know. I like my solution better. Although this is pretty simple though. Let's just read through this. First, second. They kept 2, right? They kept 2. So they don't use okay, keep 2. And everything. If it's this second, 9 times second mod n. If it's 1, second equals f equals 2, f equals this. Else, hold on. This might actually be simpler than my solution. Let's try to understand this. So, it's just soaking water. It'll come off. First and the second. So the second is going to be, if it's this, it's going to be 9. Otherwise, if it's 0, it's going to be 0. Otherwise, it's going to be 1. That's correct. And then for this, 10 per second. Okay. So first, that's true. First is 1. If we do this as a 1, then we don't have to get this situation. Yeah. Yeah, this should be 1. If this is 1, right, and then I don't have to consider this because I don't have to consider this. If it's smaller than 0, we still have to. No, it can be like this. if this is larger equal to 0 and then we return this, otherwise just return this, right? And yep, I think this one shall work as well. Yep, this one's working as well. So yeah, okay. And then I say, yeah, but you think about it, why do you do two values? Like, what's the purpose of two values? I mean, you need to sum them together, right? You see, you sum them together. You never really use them by itself. So pre, you know what? Yeah. And this is going to be 9. Yeah, this is going to be 9. Because we add them together. If else, it's going to be 0. If else, it's going to be 1. So basically, it's trying to do exactly the same thing as this one, right? And if this, return this. If this, and we're going to say current, we're going to equal to we can still do it. So times 6 plus, right? This times 3, right? Current equals this. And we have the mod. So oh no, we didn't mod at the end. So whenever we have a thing, we need to mod it. So we mod, else it's just going to equal to this, right? And then we turn around, and we're going to return. We'll just return 3, right? We'll just return 3. And the computation here, right? So this is just going to be pre, right? This is just going to be pre. No combine is just going to be pre. If combine, it's going to be pre. Hold on. If combine, right? If combine, that's the total. Shouldn't that just be pre? Pre is the total, right? And so what I'm trying to say is combine is pre. No, combine is pre. No combine is pre, right? So we say rest is going to be combine, right? Combine is pre times 2. Otherwise, it's going to be this pre. That's combine. If it's this, that's going to be pre plus pre, and this is going to be pre plus pre times 2. Actually, I'm going to say pre plus pre. Right? Else, no combine is going to be pre. Right? And if it's this situation, that's just going to be pre plus pre. Otherwise, that's going to be pre. And return this. Yeah? And we don't have to do these two. And we don't have to we don't have to do all these. Right? These are not necessary. And all you need to do is just to compute. And we pass. Look at that. We pass. Yeah, that's exactly the same as this one, I think. Yeah, this is given a current value, and then we just compute. Yeah, pre is 1, pre is 9. Yeah, try this. I would say update, right? Update. Um, simplify the code, right? Following the official solution. Yeah. Nope. We do not have to use array to record to record total value, the total decoding of star situation, right? Using a single value suffices. Okay, now we can see. This pass, I'm not going to read this. I'm just going to submit it. Submit. Let's see if it's any faster. 344. Look at that. 344 milliseconds. That's 82%. That's what I'm talking about. Yeah. We don't have to. Yeah, we don't have to. We just pre and pre, right? So I'm going to say pre represents the number of decoding if the char does not combine with the previous char. Pre represents the number of decoding if the char combines with the previous char. Yeah. If the combines, if it does not combine, that should be sufficient. Yeah, that's that. Right. And then this is saying if it's previous to this, then we can combine with one of them. If it's this, then to combine with two. Otherwise, we don't combine. Right? It's now we don't combine. It's the same thing. Yeah, very, very straightforward. That's it. Right, that's it. That's it. DP solution explained. Well, I don't need to explain. I know this DP solution. All right, so yeah, pretty good today. We got it. Took a long time, but we got it. All right, that's it. That's it for today. Well, tomorrow is gonna be difficult too, so I'll see you guys tomorrow. Adios.